Hi everyone, I'm Corentin Lecoq and today we'll speak about human vibrations and more specifically about the ISO standards to perform the acquisitions and the analysis. When we speak about human vibration, we may differentiate two parts, the whole body and the end arm. The whole body is more dedicated for the transportation industry. We will study the legs, the back, the neck, while the end arm part is more dedicated for handheld tools and so for operators. The principal goal is to quantify the vibration. And for this, we have two standards. We have the 2651 for whole body, and we have the 5349 for the arm part. So we can read in the standard that there is two parts for the analysis. The first part is the filtering process. We apply dedicated filters depending on the conditions we want to study. For example, there is a filter WF for the transportation sickness. There is filters for the buildings, vibrations, and so on and so on. And then the second part is the indicators. We will quantify the vibration thanks to standard indicators like RMS, peak-peak, crack factor, but we can also use more advanced indicators like MTLV, and so on and so on. All the indicators are on the standard. They are also on the OROS wiki, so you can find the link in the descriptions and just check all the indicators on our website. Okay, so now we'll make a real measurement in a car, and the goal will be to study the vibrations of the driver. So for that, I have 3-axis accelerometer in my left hand, and I have one accelerometer fixed on the seat in order to study the vibration of the seat. And we have also a microphone in the car just to study also the acoustic pressure. And for the measurement, we use an OR10, okay, on my right. It's an 8-channel analyzer. And we use also a computer with NVGate, where we will have in real time indicators, FFTs, time signal, and so on. Okay, so let's study the measurement in NVGate. So here we are in post-analysis mode, and I loaded a measurement made in the car. So here I have the signal of the 3-axial accelerometer, so axis X, Y, and Z, and here I have the signal from the accelerometer on the seat. So here what we want to study is the rotational vibrations. So the dedicated filter is the WE. So here we will use in our body vibration add-on the WE filter. So I just have to select my measurement. Here it's the measurement 5. And I will select the directions to double check that I have the good direction. So X, Y, Z, and the input 4 is in the Y direction. I save them. Here I select the WE filter. Here I select also the filters I want to apply. And here some advanced indicators we want to use for the analysis. Then I click on Start Processing. Okay, so the calculation is complete, and now we will analyze the filtered signal. So I close the add-on, and here in the workspace I can see that I have a new calculation with the filtered WE measurement 5. So I will, first of all, I will display it, and we can compare both. This is the raw one, and this one is the filtered one, and we can see that we moved high frequencies
and we kept more or less the low frequencies. After that, I can choose to post-analyze this signal, and we will display some standard indicators like RMS, peak, and so on. So I close this one, and here I will display the RMS of my 4 channels to compare, and the peak of my 4 channels as well. Okay, we already have results. So we can see that for the RMS we have the highest value in the X direction and the Y, and for the Z direction we have lower values. It's completely normal as we don't have rotational vibration on the axis of the car. We only have rotational vibration on these two axes, and it's the same for peak. We have 125 millig in X and 98 millig in Y. It's the same for the seat. We have a really low level of vibration as we don't have any rotational vibration on the seat of the driver. So you can see that thanks to this indicator, this filter, it becomes really easy to compare the rotational vibration between different measurements. It could be different cars, or it could be different steady state. We can also analyze some different advanced indicators like MTVV, VDV, as we saw in the PowerPoint at the beginning of this video. And as we have dynamic filtered signal here, you can also make more advanced analysis like FFT, like octave analysis, and so on and so on. You can post-analyze these raw signal. I hope you enjoyed this video. Thank you for your time watching it, and don't hesitate to watch the other videos about Navigate 2021. Thank you. Bye.